Okay, then let's get started with our second practicals in object-oriented programming. Today, it's really about practicals. So today we will really have two live coding examples. So first we start with the two-dimensional vector, which is also related to your assignment. Then we will present assignment 1. And then we have a recap from last time. So last time in the lecture, we discussed classes in C++. And then we have a live coding about classes. So we will implement some classes and discuss it with you. And also this should prepare you well for the assignment 1. Okay, so the live coding. First, to the two-dimensional vector, what do we do today?
Yes, okay, so first let's talk about what we want to create. So we want to read an ASCII art from a text file and store this in a two-dimensional vector. So not just the lines, but really each character has its own element in a two-dimensional vector. Yeah, and then we want to print it, and that's basically everything.
Mm-hmm. So maybe you can show us how to create such a two-dimensional vector.
Yes, maybe I'll first just show you the file we want to read. We have this file here, and we just want to read it and store this in a two-dimensional vector. Okay, so as we know from last time, to create a vector, we'll first just import vector, and then in the std namespace, we can just create.
Oh, still the Copilot is on, or we will not cheat today?
Okay, so, and we want something two-dimensional. And in C, we did that with an array inside an array, or more or less an array of pointers, and each of these pointers pointed to another array. And we'll do something similar here. We'll just say, okay, the type of this vector is another vector, and inside we want to store characters. So now we have a vector of vectors, and yeah, and we'll store characters inside of that, and I'll just call this image.
So at the very beginning, does this vector contain any elements, or is it just empty?
Yes, so now if we create a vector like this, it's just empty.
Okay. So now we want to parse this file here, this sweet ASCII art. And we also discussed parsing files, I think, last time, so where we read in something from a file. And now we want to do it today, because you will use this in assignment 1 as well. And I need to specify the file name. So OOP.txt. I could hard code this, of course, but I want to use command line arguments in this case. So we need to create this argc, which stores the number of elements, and then argv that actually stores the command line arguments. And with that, we can call our program then main and OOP.txt. So this OOP.txt should be the first parameter there. Okay. How can we access this first parameter here? You should also know this from ESB. It's just argv at position 1. Remember that position 0 is the name of the executable. And we want to transfer this C string now into the C++ string first. So we create a string and call this file name. And then last time we already learned we can initialize objects with these curly brackets, which is the probably best way to do in C++, because then it really checks whether the type here can be converted to this string and would prevent us from doing something which is unwanted.
Yes, and as you might also remember from the last lecture, this now calls the constructor of a string, and we pass the C string, and this will automatically create the string with the content of the C string.
Mm-hmm. So we now have the file name, and now we want to open the file. And if you remember, we need to create this if stream, in file stream, and I'll just call it file, and again call the constructor with the file name. And now I have this file object. Okay, it's not recognized because it doesn't know the if stream yet, so you have to include it as well, and which is done with fstream. So this fstream includes this type here, so we can create the file. Now, of course, we need to check whether we can really access the file, whether this file really exists. So we can call the method whether it's open. And if it is not open, then we can just return and maybe print some error message. But for sure, we know at this point that the file is open. Okay, so now we have this file opened, and we have the image here, and maybe I move the image somehow down. And now we want to store the data of the file into this image. So we want to store all the characters here into the image here. Maybe you can show us how we can do that.
Yes, so last time we learned getLine to read from a file or from std_in, but we want to read the whole file. So we need to read until there's nothing left to read. And how we do this, I think we didn't touch on that last time. So let's just, we've prepared some slides.
Also, this is my part, right?
Yeah.
So we have getLine here. We remember you have the stream, and in our case, this would be the file. Then we need a string where we want to store what is in the file. Then we have some delimiter, which is on default the \n. We will keep it with that. But we didn't discuss the return value. And now we have two return values here. Either it is true or it is false. And it's true if we could read characters. And it's false if we cannot read characters. And we will utilize this now.
So this is exactly what we need to stop reading when there are no more characters left in the file.
Do you want to implement this first, or do you want to discuss the truth value now a bit more?
Let's just continue with the slides.
Okay, continue with the slides.
Yes, but this is technically not correct. So the return value of getLine is not really true or false, but you will see now why we said this.
But don't be bothered with that. So if we just keep this imagination that we have true and false, this is enough. But Julia give you some more technical details.
This now will be the technical explanation on what's really the return value, but you don't really need to know this. And also it's not important to use it when implementing with getLine. So getLine actually returns the first parameter you pass to it. So it's the stream you're reading from.
So in our case, this would be the file, right? Yeah.
And this stream can be converted to a Boolean, and how this is done you will learn later in this course. And this Boolean is true if the stream is in a good state and false otherwise. And for example, the stream is not in a good state if the fail bit is set of the stream. And this is done by getLine. So getLine sets the fail bit if it cannot read any characters from the stream anymore. And if this bit is set, we can just use this object that is returned from getLine to check if we can read from it, or if getLine actually did read anything.
Okay, but then maybe we go again upwards again and just keep it with this very simple explanation. Just read to remember it's true and false.
Okay. So now I'll just create a line where I'll read to. So I want to read this now line by line, and in each line I want to iterate over all characters and store it in the corresponding array. And to do this, we can use the return value of getLine to check in a while loop if there are any more characters left to read. So if we do it like that, and then getLine returns false, then we won't do anything in here, and we'll just do something if there's actually some new data in the line string that getLine read. So I'll create a new vector in here. So because this vector image now is empty, and we want to push a vector with these characters into this image vector. So
what do you want to store in this vector that you're newly creating? Like in the first iteration?
Yeah, so in the first iteration, in this vector here, I want to store all the characters in the first line, which are just these spaces and these underscores here. And I want to store this in this row vector, and then add this row vector to the image vector. So you can see here, this type in here is exactly the same as the one here. So we can add this row to the image vector. So let's iterate over the characters in the current line. And we can do this with this for each loop we already learned in the first lesson. And then push this character into the row. So we have this row, and for each character we just append it and add it to this row vector. And then at the end, when we added all characters of this line, we can just add the row vector to this image vector. And now when this while loop finishes, we have for each line, we have one vector in this image vector, and each of these vectors contains all characters of that line.
Is that clear so far, or are there already questions? Mm-hmm.
Okay, so this vector actually doesn't point to anything really. It's just an abstract representation, like a class C++ gives us that contains multiple elements. And with this vector, we can just store multiple other vectors in there, and in each of these vectors, we can store a character. So this vector doesn't really point to anything.
So like this vector really stores different rows, and a row is described again by a vector of characters.
Yeah.
Mm-hmm.
Does image pushback row copy row, or does it take a reference?
So the question was whether this last pushback copies the row vector or just returns a reference or puts a reference into image, and it's a copy. So if you're using pushback, you copy it.
Yes, we can see here that pushback actually takes a reference, but in this vector, we are storing vectors and not vector references, so at some point it needs to be copied.
How would you move it into the image?
If you don't want to copy it into this vector, you could store vector references, but this wouldn't work in this case because this vector here is destructed at the end of each iteration of the while loop.
Okay, I think then we will continue and probably need to prove whether this really works, what you did. So maybe it's a good idea that we also print what is contained in the vector. And now we have 2 dimensions, so it seems that we need to use 2 for loops. And for the first for loop, what is the data type that we expect? I could, of course, write auto here, but probably we want to write the data type here. So the outer dimension would always return std vectors of type char. And we use references here, and we iterate over the image. Why is that? Again, because each row is a vector of characters, and for that reason we need to write, or we obtain in this iteration always a vector of characters. And then we want to iterate over the elements in the row. So here this would be then a for loop of characters. Maybe it's called element in the row. And now we can print this character. So we can just print the element. And after each iteration of the outer for loop, we have printed a whole row. And then, of course, we want to add something like a new line character here. So we really iterate over the rows, and then within each row, we iterate over the elements in the row and print them, and after each row, we print the end line. And let's see whether this works. Does make run work?
Yes.
Okay, let's try it. Yeah, and it really worked. So we compiled it with the make run command, and we executed with op.txt as the first parameter. Then we have this hello world, and then we have really the image that we have stored in this op.txt. Do you have any questions regarding that, or is everything clear so far, two-dimensional vector? Here's a question, yeah?
Why do we use references in for?
So the question is why we use references here and here. Maybe I explain this part first. The vector, this two-dimensional vector, each row is a separate vector. And if we would not write here the reference, then this vector would always be copied. This means if we iterate through the first row, then the first row would be copied, that we can use it here in the for loop. And then the second row would be copied, the third row would be copied, and so on. So we'd always create copies of our image, but this is not necessary because we could just iterate through the original image. We do not need to create copies. And imagine this vector, this image would not be of size, I don't know, 10, but it would be of size of 10,000. Then we would always need to copy 10,000 characters, so it would be inefficient. And if you use the reference, then we just iterate really through the original image, through the original characters, and which is more efficient in this case.
Yes. Most of the time it does make sense to use a reference if you iterate through something like this. Yes? Just auto without the reference would also copy it, and auto with the reference would then be the reference.
I think we can also cheat a little bit. So now we have written auto reference, and you see the type is a vector reference. And if we remove this, then we just have really the copy of the row. Now you change the keyboard layout. Any further questions regarding that example? Okay, then I think we can continue.
Yes, so then let's continue with assignment 1. Okay, so some important specifications. As I said in the first introductory lecture, assignment 1 is individual work, so you will do this alone, and the deadline will be the 10th of April.
So 3 weeks roughly.
Yes, there will be 7 public test cases, 16 private test cases, and you need at least 4 public test cases to pass the course or to get a grade in the course. Okay.
No, it was correct actually.
Yes. So you need 4 public test cases to get a grade in the course, and to really get a grade, you also have to register to a team.
So in the conversely, this means if you try assignment once and you only pass 3 public test cases, it doesn't matter. You will not get the grade, so you will not get the negative grade. So you can just try it. Yes. And also, if you do a perfect assignment 1 with 23 test cases, and you decide, no, I'm not having enough time to complete the course, you can just not register to a team and you will not receive a grade. So everyone can try the assignment.
Where do you register for a team?
You will register to a team after assignment 1 in the Teach Center. But we will announce this in the next practicals. Yeah.
And maybe, so this also means that if you register to a team, you will get a negative grade if you don't contribute anything.
Yeah. And if you do not pass enough test cases, you cannot register to a team because you cannot get a grade. Okay. Then we can have a look at the upstream already today. We will release the upstream after today's lecture, and repositories will be created maybe today, maybe tomorrow, maybe latest at the weekend, but latest on the weekend you will receive your repositories. But let's check out the upstream. Maybe I need to increase the size a bit. So assignment 1, optimal tactics. Maybe some of you know the game Risk, oder Risiko auf Deutsch. It's a bit in this direction, but not really. So we tried...
Very simple.
Very simple, yeah. We try to simplify Risk as much as possible, that it fits into an assignment. But maybe you see some concepts in the assignment from Risk. So... what are the learning goals? Okay, this is very clear, foundations of classes. That's what we discussed last time in the lecture, we'll do also today. You need to use strings and you need to use files and some data structures as a vector. And then, of course, there are some specification. Please read through them carefully because you need to follow them. I just want to point out, one thing here because this is new to you. We provide you already a main.cpp. So this is like a start for your assignment where you see, okay, the main is already called and there is some part implemented. And this main file will be resetted always when it's tested on our test system. So please don't change it. Yeah, it must work with the original main. Then there are some further files that we offer. We have these utils files where there's a function to convert a string to an integer because this involves a concept that we haven't discussed so far. You can use it, you don't have to use it, you can extend this file if you like.
Yeah, so you can add more util methods if you want to.
And we offer also a third file or third group of files, a command line. So a basic command line interface is already provided for you. Probably the main function here is to read a command. So we already provide you that the user input that is entered in the program is then stored in a suitable data type that you can work with, so you don't have to handle the strings. Probably just go through this and read through that. And it should hopefully simplify it a bit. And again, you can change that and don't need to use that.
So these files won't be replaced. You can also find all of these infos in the README, but just the main will be replaced. Everything else you can change.
Okay. I think the remaining parts are on the slides. So regarding the grading, assignment 1 has 16 points out of 100 in total. Functionality is graded. We already discussed this with the 23 test cases. There are these deductions, so you need to follow the learning goals. So you need to use classes, you need to use the vector, you need to use strings and files. Probably most of the concepts, it's impossible to not use them. Then we have this specification section in the README. This is here. And also here in Notion.
And with Notion, we mean the course website.
There is also a bunch of deductions, so please go through them and check that you do not use anything of that in your assignment. So you just have to open these, and most of them are very logical.
Yes, they are just to ensure that you implement the assignment in a correct way.
Is there a big difference between this side and the ESP side, the deductions?
So with the style guide, not really, just a few things. But I think some of these deductions are just for the object-oriented part. So there are some differences of some new things.
There may be more. Okay, so we have these deductions. So these are like the bad news, and now we also have some positive news. We do not grade the code quality in this assignment. So you basically do not need to follow the style guide, but probably it's a good thing that you follow the style guide, that you have an easier life, that you can read your code better and use less time for the assignment.
Yes, and the style guide will be relevant at assignment 2.
And the second good news is that there is no assignment interview. So for assignment 1, this is a bit reduced. You just have to pass test cases and have a look on the deductions, and then it should be fine.
Yes, okay, so how do you start? Well, of course, at first, you should make yourself familiar with the files that already exist. So the main, the utils, and the command line. So, yeah. Of course, after you read the README, I think the first logical step is to look through the README. Then you need to implement some classes so that the code even compiles with the classes we provided. And I think it's a good idea to start with that. And detailed description of these classes can be found in the description folder. Yeah. So here you see a description for each of those classes. And
maybe you can go into the game.
Yeah. You see here you need to create a game header file and a CPP file, and then implement all of these things. And the methods that are listed here should be implemented, because also on some of these methods, our files we provide, they require them, so they rely on them. But you can, of course, always extend these classes with functionality that you think is needed or, more elegant.
Mm-hmm. Afterwards, probably the best thing is to continue with the parsing and the printing of the map. And the map will look very similar to our ASCII art that we presented with some extensions. So maybe it was helpful that you were here and watched the first part of our practicals. And then last but not least, of course, there is some game logic involved, and you also need to implement that. But of course, if you parse and print the map, then you already have some output that you can work with. And then afterwards, you implement the game logic, use the command line class that we provide, and I hope that it's then really straightforward to implement all the commands and finalize the assignment. There one more thing. You need help? Okay. Of course, if you have any questions, please ask on our Discord. Hope you all joined already. And if there are some more involved questions or you have any technical difficulties, you can attend the personal question hours. So like half an hour ago, I published them in the Teach Center. You can find them here. And if we go there, there should be already some dates. So already next Tuesday, there is some personal question hours on campus. And then on Friday, 5th April on Discord. And then on Tuesday, 9th April, again on the campus, which will be relevant for assignment 1. So if you have troubles with the assignment, with technical difficulties, please go there and you can talk to a tutor directly.
Yes. And on Discord, you can, of course, always ask. Also, if there are some technical problems, I implemented some fixes in the test runner, and if they cause any problems, please ask on Discord.
Okay, are there any questions regarding assignment 1? Mm-hmm.
So not yet, but I think after the lecture.
Yeah, you can open after the lecture the assignment description. Any further questions, or should we continue with the classes? I think we should continue with the classes.
So yeah, this will be again an example which will help you at the assignment.
Okay, so last time we discussed classes in C++, and I will just give you a short recap how such a class looks like. So we have the syntax that we need to write class. In C we did it with a struct, give it a name, and then we have here an attribute. So this would be very similar to a struct, the data member and the struct in C. Now we have attributes in C++, where we can store certain information that the class needs. And here down below we have also methods that the class can access. For example, this area method, where we can compute the area of the rectangle. And more importantly, we also have this special method here, which is the constructor of the class. So when we call this, or when we construct an object of this class, then this constructor is called. And in our case, it would take two arguments, the width and the height of the rectangle, and would assign it to the corresponding attributes in the class.
Yes, so this is then called an initializer list, where you can just set the value of these attributes without having to manually do it in the constructor.
And last but not least, we also have these access specifiers here, where we say private and public. And everything which is in the private section cannot be accessed from outside of the class, but everything which is in the public section can be accessed from outside of the class. So these public methods, usually not attributes, only methods, are the interface to the class.
Yes?
Is the difference between the curly braces and the round braces? Because last time we used the round braces.
It's the same difference like when you just initialize a value with a variable. If you use the round braces or the curly braces to call constructors.
So those curly braces do like more type checks. So if you want to assign a double to an integer with curly brackets, it will not work, but it would work with the ordinary brackets.
Okay.
Then let's see what we're going to do today. Do you want to introduce that?
Okay, so what is our goal? We want to store recipes, and so we want to create this class recipes, and every recipe we want to store multiple ingredients. And for each ingredient we want to store a name, a unit that this ingredient has, and then some amount.
And of course,
And of course, we want to store the ingredients in the recipe.
And last time we learned about these UML diagrams, and I tried to draw our concept in the UML diagram. Okay, well enough. So we have those two classes, and as you already mentioned, with the ingredient, we have those attributes, name, unit, and amount. And then some methods like the constructor of the ingredient and a print method for the ingredient. And for the recipe, we have those attributes, the name of the recipe and a vector, just abbreviated this here, that has ingredients because we want to store all ingredients that the recipe needs.
And maybe something to note, to this constructor for the recipe, we will just pass the name and then add recipes later on with the add ingredients later on with the set ingredient method.
Yeah, exactly. And we also have here a print method. But it's not all what we do. We also have some more methods which we didn't provide you in the UML diagram. Okay, then we can start coding, I think. Just switch to the correct folder for you. So we need the main, an ingredient HPP, and an ingredient CPP. And I think you start, right? Okay.
Yes. Okay, so the first thing we always need are include guards. So I'll just okay, and then we can start writing our header file. I already prepared this header file and the corresponding CPP file. Okay, what do we want to do? We decided to start with the ingredient class first because we'll need to use that in the recipe class. So let's create a class ingredient. And we want that this ingredient has some attribute, and I want them to be private. So what do we need? Well, we said it has a name. It has an amount, so how much we need of that ingredient. Of course, we need to include string. And now we just want some unit down here.
So with unit you mean, for example, gram or tablespoon or whatever.
And for that, we'll create an enum. And I will create this enum inside this ingredient class. So you can do that like this. And yeah, this ingredient, this unit enum class is now only scoped within this ingredient class. And to access it, you always need to go over the ingredient class, like a namespace.
Yeah, I think we will see that then later in the main, when we create ingredients.
Then just, and I don't know, teaspoon, something like this. And yeah. And now we can use this down here. So here we'll just need to write unit to store some unit in this ingredient.
Yeah, maybe you're wondering why we're always writing these underscores at the very end, because we want to follow our style guide, and now I can correct you. So we have now our basic members here in the ingredient. And now the question is whether we can already create an ingredient in our main file. So I will move here the ingredient to the right, that you can again see it. Then we create our main function. And we want to create now an ingredient here. Let's create sugar first. So if we want to use this class ingredient, we have to, of course, include it here in our main.cpp. And now we write the quotes instead of the angular brackets, and it's called ingredient.hpp. And we see, okay, we already have this ingredient sugar. But what is actually stored in these attributes now? Because we do not provide any values there, and the answer is it can be anything. So we want to really provide some concrete values for the sugar. And it would be nice if we could write this also with these curly brackets as we initialize everything. So the name would be sugar, then the amount would be, for example, I don't know, 100, and then the grams. How can we access now a member of this enum class unit? So as Julia mentioned already before, we need to go into the ingredient that we have access to this inner part of this declaration. When we're in the ingredient, we scope into the unit. Now we are here, and in the unit, we can now use the grams, for example. And now it would be really nice if this works, but it's, I don't know, it's a bit underlined. Okay, we cannot create the sugar. So now we have to create something else here. Should I also do that? Yes, I should also do that. We need a constructor here. So we really want to implement this constructor now. We do this in the HPP file. And it should be public, because we want to access from outside of the class. So we have to write public here. And how is this constructor method called? it's called the same as the class is named, what are the parameters that it takes? It takes a name of the ingredient, which will be sugar. Then it takes the double amount. And it takes unit. And in our case, we can write unit directly because we are already inside of this class definition. And we take unit. Now I run a bit out of space. And I will write my initializer list now. So we have the name to be initialized with our name. We have the amount to be initialized with the amount. And we have the unit to be initialized with the unit. So if you look at this line of code here, maybe it makes sense that we have the style guide definition with the underscore, because otherwise we have unit and unit the same name, which would not be possible. There was a question.
Do we need to write public twice, or can we write it under the above access modifier also?
Yeah, you could, of course, do something like this as well, and then you don't need the public. It depends how we want to order the attributes and methods. So we list the attributes first, and then we write the methods. For that reason, we have those two public sections. So the enum, of course, must be defined before we can create a variable of the type, and then we wanted to list the constructor later. That's why we use two public sections, but this would be possible as well. Okay, so we have now this constructor, and we call it in the main function, and now we want to see whether this really works. And of course, we could write now a print method, but we want to introduce something else today, the debugger, which you hopefully already know from C, because it's really handy. And now let's have a short look how we can start the debugger. There are different debuggers that you can use, and we will focus on the debugger of VS Code. Yeah, question? So why are there those braces? Because this is a function. This ingredient thing is a function with an empty body. So here we could, for example, print something or do some calculation, but we don't need to do this in this ingredient constructor. But there would be this the place for it, and if it's empty, we still need to write those brackets here. Yeah, so this is all part of the constructor then. And everything which is written in between would be executed when the object is constructed.
If we...
Could I write just a method, it's not a constructor? So, because I want to use every constructor, or like every method that begins with the same name in space ingredient, the constructor, and also like normal function with function body at the same time?
Yes. So every constructor is also a function that gets called when this class is created. We could also omit those curly brackets here, but then this would just be a declaration, and we would need to implement some body of that function in the CPP file.
So every constructor is every function a constructor?
No, not every function. So, not every function is a constructor, but every constructor is a function.
So like I can have methods on the class that don't construct the class?
Yes. We will see that soon.
So we wanted to start a debugger in VS Code. There is one requirement that you need. You need an extension called code LLDB. So you need this extension here, which I have already installed. Then you click on this run and debug part on the very left side. We run and debug, choose LLDB. This is okay that we get this error message because we need to specify this launch.json. And there are probably two important things that we need to do. We need to specify here the path to the executable. This would usually be just the executable itself. So in our case, we are in live coding recipes and we would call it main, but I have to write now the whole path here because I'm in another workspace folder. Recipes, and then it will be called main.
So the workspace folder we have here in this launch.json is always the folder you have opened in VS Code.
And in our case, this is unfortunately another folder than the project is directly in, so you have to go there. But usually you just need to specify the file that you want to debug. And if you have arguments, like we had this before with this OOP.txt, then you would specify them here, for example, this way. But in our case, now we do not have any arguments. You can just leave it as it is. Okay, now launch.json should be fine. Then we compile. Okay, we just have make.
It's make main.
Make main. Okay, some warnings, but it doesn't matter. We go back to this run and debug part, and then we can just press on the run button, and it hopefully works. And it worked. So I cheated a little bit because I already set the breakpoint here before, that we stop here. And then on the left side, you can see these local variables. And you see that here is a local variable called sugar. And then it has a name, which is a string, which is not displayed here, unfortunately, because about C++. But we see we have amount 100 stored, and the unit is gram. So we could verify now that really the correct parameters are stored in our ingredient. Okay, then I think we stop the debugger again, and our sugar is fine.
We need to create the sugar object in the main function, because if otherwise we create it in a different function, how can we make sure we can access it outside of the function's code?
So the question was, if we need to create the sugar variable in the main function, and if we didn't, how we would access it? Was that the question? Okay. Yeah, so if we would have created it in another function, then of course, just like with structs, we can use it in this other function. And if we want to return it, we can just specify ingredient as the return type and then return sugar, and then we can access it in the function that called this function. Or we could, for example, I think that's in the lecture today, also store it on the heap, but how you do this in C++ will be content of today's lecture.
So this basically the sugar is not more than a bit advanced integer. So you can pass this integer or the sugar to other functions. You can return it. It behaves more or less the same.
Yes, just like the structs in C.
Okay. Maybe we have now seen the sugar in the debugger, but maybe we can write now a method that prints this sugar to the terminal.
So, like we said before, we can also create other functions, not just constructors. In this, here in this class, for example, we could create a print function which takes no arguments, and we write const here. I think this will also be part of today's lecture.
But you have seen const last lecture when we implemented getters. Just reuse it here. This is not needed for it to work, but we just write it now so that you already get in the habit of writing it, because it's just good practice, and you will hear the reason why today. So, and now to implement a method, we need to specify which class it's from. So we need to write ingredient colon print, and it needs to have the same type signature, so it also needs to have the same const and return value and parameters.
for this to be the same methods.
And you implement this function now in the corresponding CPP file.
Yes, so I'm here in ingredient.cpp, and I need to include the header file ingredient.hpp, and then I can implement it. Let's at first just print the name. Oops. So to do this, I can just write. Let's start with the. Just with the amount. So I want to write amount, then the name of amount. Then I want to write the unit of the ingredient, and then the name of the ingredient. I think this makes the most sense. And of course, if I want to print something, I'll need to include IO stream. Yes?
Why is the include for the IO stream here and not in the HTTP file? Why are they included?
We could, of course, always include this in the HTTP file, and this would work. But I think you should always include this stuff there where you need it. And we don't need IO stream in the header file. We are not using any classes or functions from IO stream in the header file, and therefore I'll just import it in the CPP file. But both would work. Okay, then how can we print the unit if we just have this enum class here? Does anybody have an idea? No?
Nobody can print the unit.
Okay, so we could do it just like we did it in C and have a switch, and depending on what the value is of our unit variable, print something different. So we have switch unit, and then we need to write a case. Okay, I need unit.
And what is important about switch cases? Not forgetting the break.
Yeah.
I actually have a question now. So we have this switch case here. We have this unit gram. And when I wrote the main.cpp before, I needed to write ingredient unit gram. Why is it sufficient that we write unit gram here?
Yeah, this is because in this function, we are already in the ingredient class. So we can use anything, also like the member variables here. We can just access it without any specifier. Exactly. Yeah, let's now just print everything we need. Okay. And now let's just print the name of the ingredient. Okay. And with this method now, we can print our ingredient.
So we do this in the main function.
Okay, we can now, down here, just call our print function on the ingredient we just created. So we can just access it like any other member, like we did with struct, but now it's a function and we can call it.
Then maybe we can print it and see whether the sugar really has the right values.
Let's run it, and yes, we can see that we printed the values we expected.
Okay. So now we have this ingredient class. Maybe before we continue with the recipe, is this clear so far, or other questions regarding classes and attributes and methods? Mm-hmm.
Okay, so I think the question mark was if we could create these attributes we have in here, so the name, the amount, and the unit in the public part of the class, and if we then could just access these attributes from the main. Was that? Yeah. So this in the main calls our constructor. Yeah, the thing we have down there. And if we would make these attributes public, we could just set them in the main like this and access them.
But it's something that we really want to avoid, because we don't want anyone else to set our attributes instead of our class itself. If we want to implement something like this here, then we want to use a setter for classes, because we want to check whether this value is an appropriate value for our class.
Yes, most often we want that our class objects are in a state that we expect, and most of the time we'll just do these attributes, make them private, and then create setters where we can check some conditions if everything is correct, and then save this. Okay, so do we still need the constructor if we have these attributes public? Then no, I think then we can access these attributes and create this object with the default constructor. Yes.
Okay, then probably we continue with the recipe. Just save this. And now we have a new class, and for a new class we always also create a new HPP and CPP file. And again, new class, we need the include guards. And now we name our class recipe. What did we say that we want to store in our recipe? We want to include as a member the name of the recipe. So this is very similar to the ingredient. And yeah, we need to include the string here as well. But we also want to create now a list of the ingredients that should be part of the recipe.
So we want multiple, not just one.
And for that reason, we use a data structure that we've seen today already. So use again this vector. And what is the type of the elements that are contained in the actor? This is ingredient. And call them ingredients. Okay, what do we need? We need to include the vector, of course. And if we want to use the ingredients, we also need to include the ingredient.hpp file. And now we can access this type of these types, and we can create this vector here. And I can also implement the constructor, because we've seen this already. So again, it's the name of the class. In our case, it just takes one argument, the name, and we write our initializer list. So we assign the name to the name, and the ingredients should be an empty vector. So we do not write anything here. And again, we need the function body of the constructor, even if we do not fill anything there. Okay, and now we have our recipe class. haven't implemented anything in the CPP yet. And I think I can also create our first recipe. So for that, we need to include it, of course, recipe.hpp. And what do we want to cook today?
Let's make a salad.
A salad with 100 grams of sugar. Okay, so we need to specify the name, of course, so it's a salad. Okay, we have our salad, very fine. How can we add now the ingredients to this salad?
Yes, so these ingredients here are private and we can't access them. And therefore, I want to write a method where we can add these ingredients. And I'll just call this method set ingredient. So like here. And I'll just pass an ingredient like this, and I'll implement it in the CPP file. As always, I need to include the recipe.hpp, and I'll just copy the function declaration because it needs to be exactly the same, and we need to specify from which class we want to implement this function. So we write this recipe here. Okay, what do we want to do here? We want to just add the ingredients to the ingredients, and then with the method pushpack, which we learned last time, we can just add the ingredient. Yes, to this vector of ingredients. Now let's look at the main function, and now let's add the sugar to our salad. And maybe, okay, we can see that, so let's look again with the debugger. We still have the breakpoint here, so that's fine. Let's run it with the debugger.
Have you compiled?
No.
Okay. Yeah.
Okay. Okay, and we can see that we are down here now, and we can inspect our recipe, and we can see that ingredients, we have size 1, and the first element, for some reason the debugger can't display the string, but it's our sugar. We can see it here.
Yeah. So we've created now our first recipe with one ingredient. Now, of course, would be interesting to add more ingredients, maybe more ingredients that are more useful for a salad. So we could add a new ingredient, for example, salt. I will write it directly here. So we create an ingredient.
Maybe close it.
Okay, I close it. So that you can see it better. A new ingredient, which is the salt. Maybe a more reasonable amount, 10 grams. Ingredient unit. And then we have the gram here. Okay. And maybe at a later stage, I think, okay, this sugar is not very useful in our salad. And not 100 grams of sugar. Maybe we should reduce that a bit, very tiny little bit. So now I want to do something like set ingredient and pass now a sugar. I probably should name the salt with capitals and say, okay, now I just insert 5 grams of sugar into our salad. Now the question is, what is happening now? What is contained in our recipe if we do it like this? How many ingredients do we have?
3.
Yeah, we have 3 ingredients. Now
we have 105 grams of sugar.
No, that's the completely wrong thing. I wanted to reduce the sugar, and now I have more sugar. We can also check it in the debugger. So if we go into our salad, we say ingredient size equals 3. So we have at 2, we have this 5 grams of sugar, and here we have those 100 grams of sugar. So maybe we can implement the set ingredient method more intelligent, that it overrides ingredients that are already contained in this list. Maybe you can do that.
Okay, so let's go back to our set ingredient function. And maybe let's not just directly add the ingredient, but let's try to find an ingredient in our recipe that has, for example, the same name. And if there already exists an ingredient with the same name, we want to override it. That's why I call it the function set ingredient, because we also want to set ingredients. So to do this, I'll create a for loop, and now we'll call this ingredient and this ingredient to add. And I'll iterate over the ingredients. And very important, I need now a reference, because what do I want to do? I want to change an ingredient, and if I didn't use this reference here, it would just be copied and I would change a copy. But I want to directly change the ingredient that's in our vector, and therefore I use a reference. So, and now if this new ingredient to add, and okay, so I want to access the name now, but I can't access it because it's private. So what do we need? We need to write a getter in our ingredient class.
So because we have here in the ingredient class the name in the private section, we cannot access it directly here.
Yes. So here we see, okay, it's private, we can access it, but I want to compare the name right now. So I'll create a get name getter. I'll just implement it here now, like this, and this just returns the name of our ingredient. And I can use this here now, get name, and then the ingredient here. So we compare this ingredient, the name, we compare it with this ingredient. And because these are C++ strings now and not C strings, we can also compare them with equal equals. So this is really nice. And now if they are the same, I just want to set the ingredient to the ingredient we want to add and then return. This return is important because else we would again add it twice. And I renamed this here. So I need to copy it.
Okay. Then let's have a look whether now the sugar got replaced. You need to go into the other terminal to compile it in a second.
Okay. So we still have no print method for the recipe, so we need to use the debugger. We still have the breakpoint, so let's run this. We have our salad here. Let's check the ingredients, and right now we already see, okay, the size is only 2. So
it looks already very good.
Yes, it seems like it worked. Let's check this. We have 0, which is the sugar, and it's only at 5 grams.
Yes.
And we have the salt down here as the second element. Yes, we can see that here. Okay, so it seems like this worked.
Are there any questions regarding that? Okay, everything was clear,
Yes.
obviously.
Yes, we will of course publish this code, and you can always ask questions on Discord. Do you want to skip the last part and keep that for next time?
Or does anyone want to see the last part that we have prepared, or should we make a break? So who is for the last part? Who is for the break? Okay, it seems more that we go into the break now. And when do we start with the lecture? At half? Okay, 25.
Yes, okay.
So in 12 minutes, 11 minutes, the lecture starts. Thank you.